Welcome to Trigonometry for Pre-Calc Math 11, and today we're taking a look at determining angles in all quadrants. Basically, in the previous section we determined what the ratio of sides of a triangle would be given a standard position angle. So we started with an angle and we came up with the ratio of sides. So the ratio was either positive or negative, depending on which ratio we're talking about and in which quadrant the standard position angle fell. So if you remember back, we had the cast rule, and the cast rule just told us in which quadrants cosine, all of them, sine, and tangent were positive. So now we are concerned with the reverse of this, basically the reverse process. We want to start with a ratio and work backwards to find the position angle. So let's take a look at an example. We want to solve for theta to the nearest degree, and I'm going to tell you that theta has to be between 0 and 360 degrees, and we have cos theta equals negative 0.978. So I have a couple of steps off to the side here. Notice determining which quadrants that the angle could be based on the cast rule. If we take a look at a little cast rule, let me just draw a little CAST. Cosine is positive in C and A, so it's negative in T and S. We are looking for where cosine is negative. So what I'm going to do is I'm going to just draw two little Cartesian coordinate grids. One line, one terminal arm in the sine quadrant, that's quadrant 2, and one line in the tangent quadrant, which is quadrant 3, because that's where cosine's negative. I want to drop any negative sign. This is actually a useful point when we talk about using a calculator. The negative sign indicates what quadrants we're in. It doesn't really do much for the angle, it just tells us what quadrants we're in. So when we want to find the reference angle, we can just go with cos theta equals 0.978. And what we're going to do is we're going to take the arc cos of 0.978, or second function cos, and we find a reference angle. Remember, reference angle has to always be between 0 and 90 degrees. And here it's 12.04 or 12 degrees. So what that means is that reference angle is the amount between the terminal arm and the x-axis. So if we're looking for standard position angles, this theta 1, the two values we're using are the 180, and we are short of 180 by 12 degrees, so we get 168 degrees. If we take a look at the second one, theta 2, we are 180 degrees plus a little bit more. 180 degrees plus the 12 degrees gives us 192 degrees. So those are the two solutions. We can potentially have two answers. That's a nice, that's an inexact value type question. We could do the same thing with an exact value type question. In this case, when sine theta equals 1 over root 2, it's actually a little bit easier because we don't need to use our calculator. We can just look at an exact value triangle. So if you want, why don't you hit pause there, try and give this one a try. Sine is a positive 1 over root 2. Sine's positive in quadrant 1 and quadrant 2. Off to the side here, let me draw a little triangle. I know it's a 45 degree angle triangle because it is the only one with a 1, 1, root 2 kind of thing going on. So that tells me my reference angle must be 45 degrees. In quadrant 1 here, that one's pretty easy. Theta 1 is 45 degrees. You don't have to do too much work there. In quadrant 2 here, theta 2 would be 180 degrees minus 45 degrees, which is 135 degrees. So because it's an exact value triangle, we only have two options here. The 1 over root 2 has to come from that 45 degree triangle. That must be the reference angle, and we can go on from there. Just making questions a little bit more difficult, I think, or a little bit building a little bit more. given that tan theta is negative 3/7. So right away, when I see something like that, I think to myself, okay, if tan is negative, it has to either be in quadrant, let's see, quadrant 2 or quadrant 4 if tan is negative. Then they tell me that theta is between 90 and 180. Well, 90 is straight up and 180 is straight left, so we must be talking about just that answer in the top left. So we're in the top left, we're in quadrant 2. Determine the exact value of the other two trigonometric ratios. Well, let's see here. Let's maybe draw this a little bit better. We have a triangle in quadrant 2. There's theta sub r. Its negative tangent, is opposite, which is 3/7, and the negative must be on the left. I can find out r using Pythagoras. 3 squared plus negative 7 squared. 9 plus 49 is root 58. So sine theta as an exact value, sine is opposite, so 3/root 58 works great. Cos theta is adjacent, so that's negative 7/root 58. And we already had tan as negative 3/7. So let's go back to the question. Determine the value of theta to the nearest degree. Let's go with the positive sine theta. Theta is arc sine, or second function sine, inverse sine of 3/root 58. You can just roll that through your calculator, and we should end up with 23.2 degrees as the reference angle. So the standard position angle is, because we're in quadrant 2, 180 minus 23.2 degrees, which if we round, works out to be 157 degrees. So a couple of bits there. We can draw the triangle in standard position. Kind of almost gives us a terminal point. From there we can figure out the radius, the hypotenuse of the triangle, and exact values for sine theta and cos theta. So here's a great example. We have a point, -5, -2. Why don't you guys give this a try? Same kind of idea, starting with a point. So -5, -2, that's left 5, down 2. We are in quadrant 3. There's the hypotenuse of this triangle, r squared, and we could figure that out again. A nice exact value, again 4 plus, if you square negative, it's going to become positive. We have 29, so r is root 29. We want to determine all the trig ratios. We have sine theta, sine is opposite, -2/root 29. Cos theta is adjacent over hypotenuse, so -5/root 29. And tan theta uses nicely the point we're actually given, so -2/-5, which is positive 2/5. Let's go with the positive value here. Reference angle is going to be arctan of 2/5. Arctan of 2/5 is 21.8 degrees, basically 22 degrees. And our standard position angle is, because we're in quadrant 3, 180 degrees plus that 22 degrees, which gives us 202 degrees. So I'm kind of tearing through this pretty quickly, but after last unit should be fairly straightforward. You have a point, you can plot that point, you can figure out the ratio of sides based on that. Sometimes it's going to be multiple answers just based on cast rule, and in this case, if it's just a point, you should just be able to pick off the ratios. This ends basically the reverse process, which is determining angles in all quadrants for Pre-Calculus Math 11.